alone can create a lot of job. However, the challenge is there is not hydrogen available in nature. Hydrogen is either within natural gas, methane, or within water. So we have to somehow produce hydrogen. Okay, so there are many different ways of producing hydrogen. One, what we want is a green hydrogen. Green hydrogen is produced from water and a process called electrolysis. So we need electricity. We apply electricity into water, break it down into hydrogen and oxygen. Now, the hydrogen at an industrial scale is produced from natural gas. Of course, when you break down natural gas, we produce carbon dioxide. And if we emit the carbon dioxide, we are again creating atmospheric pollution. So if we can have natural gas with carbon capture and storage, then we can have what you call a blue hydrogen. So some of the emission coming out from natural gas splitting can be captured using oil and gas, carbon capture and storage. In terms of hydrogen transport, we can transport it in a gaseous form through the pipeline. You can transport it in liquid form. And then there is a new breakthrough, which is called liquid organic hydrogen carrier. What it means is that you get hydrogen lean fluid, something like toluene, and we attach hydrogen with the toluene and create a hydrogen-rich liquid called methyl cyclohexane. Methyl cyclohexane. So then this is a liquid, and we can transport that liquid through a pipeline or any other process, and then we can get the hydrogen out from this liquid again. Okay, so that way you can transport hydrogen because hydrogen is a very light gas. You have to compress it significantly to push it through the pipeline and things like that. So this is a new technology coming up in hydrogen transport. For the time being, green hydrogen production is 10 times expensive than gray hydrogen. So roughly, if you look at the price, is actually 10 kg, $10 per kg is green hydrogen and $1 per kg is gray hydrogen. Gray hydrogen is the hydrogen produced from natural gas without carbon capture and storage. So you take a natural gas, you what you call you mixed it with steam at a high temperature, high pressure, in presence of catalyst, and it produces carbon dioxide as well as hydrogen. What is the advantage of hydrogen? Hydrogen can play a role because some of those very difficult sector where you want to decarbonize, where hydrogen can play a role. Something like aviation, something like shipping, long distance shipping or aviation, where hydrogen can play a role. Though hydrogen is very expensive, and but it can play a role. And if you look at this world map here, that shows different size of the project and different location of the project. So maybe all over the world, a lot of hydrogen project is going on now. As my colleague Sarah said, hydrogen. Uh, Aberdeen is looking to be a hydrogen hub, lot of hydrogen type industrial work as well as fundamental research going on at two universities in hydrogen. So in order to produce hydrogen at a cheaper price, as I said, we have to bring down the price here, green hydrogen. We have been doing our research here at Robert Gordon University. Now I am going to talk about our research. So if you look at the headline here, you can see that RGU researcher make steam-based hydrogen production breakthrough. So this is me. Obviously, you can recognize me. These are my colleague, Professor Nazimul Faisal, Dr. Anil Prathuro, and two researchers working on this project, Dr. Victoria and Dr. Ajit. So what we did, we come up with a new electrolyzer which ran at a high temperature. If you can see my hand, actually I am holding that electrolyzer in front of me. So it's nothing but a tube here. So you can see a tube. And this tube is made of stainless steel or titanium, very hard tube, and we can then heat it up to maybe 800 degrees Celsius. As a result, in order to produce hydrogen, we need less amount of electricity. We reduce the electrical input and we use heat, and that heat can come from waste heat source or from nuclear plant. So how it works? We have this tube here. I'm showing that tube here, this figure. On top of the tube, we put three different material. One is what we call YSZ, erythria supported zirconia, which is porous material, with mixed with nickel oxide. Then we have another material we call OSZ again, very dense, and GDC, a material which is very dense again, and we create a cathode, then electrolyte, then anode, three different layer. And each of these material, we balance different type of material, its porosity, its thickness, and things like that. And then we apply electricity onto that system. We pass steam through this tube, and hydrogen comes out at the end of the tube. So this is the tube again. We are applying different layer of coating. First of all, we have stainless steel. On top of that, we have put silver as a current collector. Then we have put nickel and YSZ. So you can see the color changes because of the different material we are putting in. On top of that, we put again YSJ, then GDC. We did it by manual dip coating, and at the end we create a what you call a anode. So we have a cathode, electrolyte, anode, three layer. But we have balanced the thickness and porosity of different layer to make the maximum efficiency out of the system. And then we just roughly did a connection between cathode and anode, very crude connection. So this side, inner side is cathode, outer side is anode, and we pass steam through that tube. Obviously, we have done a lot of microstructure analysis, and we have looked at what is the thickness of different type of anode, cathode. Cathode thickness is about 112 micron, electrolyte is 8 micron, and anode is 49 micron. We have to optimize those sizes and the porosity. And then we run it at different temperature, and we found, if you look at this blue line is the most efficient line, and that produce about for a 1.2 volt, it produce significantly high current density than whatever electrolyzer is in the market. So we are very pleased that we have developed an electrolyzer which can produce hydrogen, green hydrogen, at a very high rate compared to our what is there in the market. Okay, so that's hydrogen. Now let's move on to hydropower. What you have, hydropower is a green energy, of course, and currently 16% of the global electricity is produced from hydropower. But it doesn't have a perception problem because we have to create a mega dam, and that may face backlash from environmentalists, from public, and from different sources. The future, if you have the old hydroelectric power system, we have to have retrofitting the old system now, old plant, because it's coming towards the end of their life, and we have to have prioritize ecosystem. But if you look at the forecast, this line here, hydro, it has a significant role to play even at 2030 and down to 2050. And currently, this is the most renewable, 16% of the global electricity is produced from hydroelectric. And it is the largest source of renewable electricity today. As I said, it has got a perception problem currently. You have to create a mega dam, you have to collect water, and you can have problem, social and environmental problem. Thousands of people were forcefully removed from their homes to make room for flooded reservoir. And this actually happened in the country that I came from, Bangladesh, and that created insurgency of the people, because those people were mainly from Chakma tribe, and they started fighting against the government's arms rebellion that continued for more than 20 years and things like that. So there are a lot of bad things happen basically for creating hydroelectric power. Today, of course, we are fortunate. Full consideration of these concerns has become a prerequisite to get hydropower permission. But we can use hydropower in different way. So if you think about hydrokinetic turbine, we can generate electricity from smaller modular uh, hydrokinetic turbine, maybe the size of 5 kilowatt to 10 kilowatt, small size. It uh, take energy from the moving water. So you have a river where the flow rate is very high, about 2 meter per second or 3 meter per second. We can use that water to extract hydrokinetic energy. It doesn't require dam. It doesn't require big construction. It minimizes environmental impact and things like that. And this type of hydrokinetic turbine can be put in remote area where it's not easy to supply diesel to run diesel engine. It's not easy to supply solar or solar energy or wind energy in those remote near the water villages. We can have hydrokinetic turbine and generate electricity locally and supply to these villages. So we have been working with IIT Dhanbad in India in collaboration uh, to develop this type of turbine. And the project we are calling it Hydro Innovate. And we have now developed a computer simulation code that create the blade design for turbine. So we can come up with different type of aerofoil or hydrofoil design, its shape, and importantly, twist angle. What will be the twist angle at the root, and what will be the twist angle at the tip, and that balancing the twist angle of the blade give you the maximum efficiency. So we have written a code here, and we are going to develop this turbine and uh, put it in water. Another energy, which can be a future, is bioenergy, which is waste to what? Say again? There is a test. There is a test for fire alarm today in our office, but give me a few minutes. Okay. So another energy source is biomass. So we can look at agricultural waste, algae, municipal waste, even solid waste, and either you can burn it, generate electricity from the either we burn it, we create a heat, and that heat produce steam, and then we run a steam engine and things like that, steam turbine, or we can have anaerobic digestion and create biogas or syngas. So even in the villages like that, we can have a anaerobic digestion system and produce syngas that can be used for cooking and things like that individually. Bioenergy is a circular economy. That means in this process, we release carbon dioxide, but that carbon dioxide is consumed by the tree and the plant and things like that, and we use the tree again. So it's a whole system is recycled. And if you look at the future, currently we have 6% of the energy demand is from bioenergy, and we can expand that significantly up to 2030 and things like that. Advantage of bioenergy is that from the biofuel syngas we can convert into different type of expensive fuel, something like SAF, um, aviation fuel, synthetic aviation fuel, and things like that. Okay, so if you think about certain area where it's very difficult to decarbonize, especially aviation and things like that, biogas can be converted into different process into synthetic aviation fuel. And in future, as you said, it can supply up to 6% of the total energy. That's the forecast. Taking it from about how much now is about less than about 5% to taking it up to 6%. And it can be used as a e-fuel, as I said. It can be used for hydrogen generation. It can be used for solid biomass, biogas, liquid biofuel. So you can see a lot of areas this bio mass related fuel can be used for transport, for building heating, for industry and things like that. Okay. Now, wind energy. Again, Aberdeen here, we are actually quite advanced in having offshore wind. Some of the offshore wind is fixed into the seabed, but we are going deep into the sea and having floating offshore wind. We have high wind Scotland project, which is floating turbine going into deep sea, and we have 15 megawatt turbine. These are massive, maybe almost 120-meter diameter kind of thing, massive, massive turbine. And on top of wind turbine, we have got a lot of digital tools now, AI-based predictive maintenance, and that saving lot of maintenance cost. So it used to be very expensive, but because of the sheer scale and smart technology and continuous research, deployment, and we are learning through demonstration. So offshore wind is actually quite significant in Scotland, and it is way ahead of all the renewable energy production in Scotland. We are also doing some research in our school in wind energy. So this type of wind energy is quite well established in terms of his design, in terms of his sizes and things like that. What we are looking at is digital twin, AI technology for maintenance, predictive maintenance, and things like that. But in terms of vertical axis wind turbine, which is not yet deployed, this type of turbine can be used in urban setting, near at your home or in the city street and things like that. And this type of turbine still has got low efficiency, but we can develop that. So we have come up with a 16. Usually these blades number from 3 to 4, but we come up with a 12 bladed design mainly to get a better startup. So at a low wind speed, we can start it up and then it's keep going. And we have all the guide vane on top of those turbine to get better efficiency. So in future, this type of turbine, though it's looking horizontal, we actually put it vertical, and then it can be in a city street where the velocity maybe 5 meter per second or 4 meter per second, we can use those wind speed to generate a small amount of electricity. Ongoing research in our lab. Okay, now moving on to geothermal heating. It has got geothermal energy. It has got a lot of potential. If you think about Iceland, 90% of the renewable energy, and mostly they are coming from geothermal. So if you go deep and deep and deep, you get a lot of heat there. We can use that heat to generate electricity. This geothermal advantage is always one, renewable, always there. So it doesn't vary between daytime, nighttime. It's always there. Challenge is high drilling cost. So in UK, there is no dedicated drilling setup for geothermal uh, drilling, geothermal well drilling. So whatever drilling mechanism we have is coming from oil and gas, and rent of those drilling is actually very expensive, prohibitively expensive. So if you can reduce the drilling cost, if somebody come up with a smaller drilling rig that can be used for geothermal uh, well drilling, then it will be a lot cheaper to come up with some energy from geothermal. Okay, what is the forecast and what is the potential? If you look at this dotted line at the bottom, see this red line, hardly visible, right? So I can put my pointer here, laser pointer here. This is the total energy, global installed power capacity of all sources now, here at this bottom. And if you think about all the total energy available within the world, what we can get, maximum we can get is solar, that has the highest potential, and second highest potential is geothermal. If you look at the color coded, that said how deep you have to dig to get the heat. So if you go up to 0.5 to 3 kilometer, you can still get the amount of energy that is the global installed power capacity of all sources now, only 3 kilometer. If you go deep, 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 you get more heat, and 7 to 8 kilometer deep, you get the second highest total available energy sources after solar. These are the potential. If you compare that, what we are producing now is just here at the bottom. So you can see the potential of geothermal uh, energy and is there. So, little bit of interesting research that we have been doing on the concept of geothermal, but we are not going into deep into kilometer. If you look at these are the kilometer size, zero point 0.5 to 3 kilometer to get the lot of heat. We are actually doing something else. We are trying to go into up to 2 meter deep and trying to use that earth temperature to cool down atmospheric air. So the project we are doing in Kenya, there is a remote village in Kenya. We have some local partner here. Uh, it's me here, my colleague, Professor Stephen Vatican and Professor Yadilian there. So what we did, we dig only 2 meter deep. We put some pipeline here, and then we have got consent from the local people, and this filled it up. So what we have, this is the opening. We suck air in into the pipe. It goes through the ground. It cools down, and then we put this air, cold air, into their room here. And this is the inside opening. And to drive air, we put a solar-driven blower or a fan. So this is very cheap fan, and it's we don't need very high speed actually. Very small fan can extract air into the room and providing cold air inside the room. So same geothermal concept, but we are using that to cool down air and providing cooling to a remote village in Kenya. That's our research. Now we are looking into nuclear. Of course, this is a controversial, but it could be a game changer because it's purely uh, renewable. There is no emission coming from uh, nuclear plant. And in the future, we are looking at factory-built, scalable, safer nuclear plant, what we call a small modular reactor. So these are the reactor built in factory, and then you install it in your site. Of course, it will be a lot cheaper if you come up with this type of solution. We have a stigma of nuclear, as I said, and many of the politicians is not talking about nuclear, but it could be smaller, it could be cheaper, it could be faster to deploy, and is another source of decarbonize the electricity generation. If you look at the world, who is the biggest deployer of renewable nuclear plant, is currently just under 10% of the global generation. And after hydropower, for the time being, after hydropower is the second largest uh, low emission electricity today after hydropower. Hydropower is 16% and nuclear is 10% of the global generation. Of those countries, if you look at the France, which is way ahead, 65% of their electricity is generated from nuclear. Next is Slovak Republic, Ukraine, Hungary, Finland. We thought Japan will be on top, but Japan is actually way down, about less than 10% of the renewable next percent of the electricity is generated from nuclear. UK again quite low, less than 15%. They are trying to build some new nuclear plant and things like that. Surprisingly, China is also less than 5%. However, in terms of technology and in terms of all the future plant that is in design process or is installed in the next few years, all are either designed by China or by Russia. These are the two countries which has the technology of nuclear plant, and they can install really quickly and safely. So what is the barrier? Of course, cost is a barrier, because new renewable energy is very expensive for the time being. So what you can do, we can use some of the policy lever to make renewable energy more attractive. That can include carbon pricing and carbon tax, or you can have R&D tax credit, like in USA they had the Inflation Reduction Act and things like that. They invested a lot of tax credit for research and development in renewable energy. Another roadblock, especially in the Western countries, is what you call NIMBYism. So if you want to do anything, there is always a local protest, opposition to local projects. So in UK, we cannot. There is a ban on putting onshore wind turbine because a lot of people are opposed to that. Of course, that the advantage that brought in, actually UK become expert in offshore wind generation. But always, if you want to put any power plant or any of the project, especially in UK, there is a lot of opposition. So technology alone cannot save us. We need the policy to prioritize, to penalize pollution at the one hand and to reward innovation on the other hand. Otherwise, progress will stall. So we need to have a policy lever that will help to bring it new innovative product and process into the system. Main thing is the electricity generation. If you can electrify everything, if you can electrify everything like car where we are traveling, so if you have a electrical battery, our heating at home in UK it is done by uh, gas, but instead of gas, if you can have an electrical heater, if you can electrify everything, then it's easy to decarbonize. So electricity sector, renewable energy share forecast to expand from 30% in 2023 to 46% in 2030. So this is about electrical generation using renewable energy. But then we have other sources of energy we need, which is for industry. We need energy for heating, and we need energy for transport. Transport can be decarbonized using electrical vehicle, electrical battery, and things like that. So if you think about 2050, where we want to achieve net zero, how we can do that? First of all, electrification. We need 90% of the electricity generation from renewables. And this, out of 90%, 70% will come from solar and wind. So these are the two big advanced technologies already here. And the more and more we do those, you can just build up applying this technology. We need to have energy efficiency in improvement. So we have to have buildings that has got to be more efficient in terms of heating, cooling. We need to have electrical vehicle, more efficient vehicle, home appliances if you're using a fridge, washing machine, those has to be much more efficient in terms of electric consumption. Electrification is the key, so we can have car, bus, trucks, heat pumps, everything building. Electrical furnace for steel production. So those are electrification leading to uh, achieving net zero. As I said, generation of electricity from renewable is easy comparatively in other sectors. So if you can electrify everything, you can achieve net zero. Bioenergy will play a big role because some of these plane, ship, the transport, long distance transport, where electrification is not possible, then we can use biomethane or sustainable aviation fuel. Those are coming from bioenergy. So low emission fuel we can generate from bioenergy. And carbon capture and storage is the another area where some of the emissions, some of we simply cannot do anything, so we have to have carbon capture and storage. In terms of achieving net zero again, I'm coming back to hydrogen because we in our school we have a massive research program going on hydrogen, and it has got significant future if you can produce hydrogen at a very low cost. If you cannot produce hydrogen at low cost, still it will have some role in some specific market because some of those very difficult industry or even going back to ships, planes, heavy industry, some places is simply not possible for electrification or bioenergy may not be useful. So then hydrogen and hydrogen based fuel can have a big role there. And finally, we have to have our behavior changes. We have to increase our walking, cycling, use of public transport, and giving up long haul flights. Okay. Um, so, in conclusion, there is not a single one solution. There is no silver bullet. It will be a combination of different renewable energy. We need investor to fund scalable pilot project and demonstration project. We can demonstrate different technology work. Policymakers should help to streamline the permits, to help prioritize or incentivize renewable energy, incentivize research and things. Public should support local project. You have to engage with the public, make them educated into local project, show them the benefit of any new project that coming to their area. Finally, is future is not solar or nuclear. It is a combination of solar and nuclear and wind and maybe something new. And we have to think about champion the solution that fit each community's need. So we don't bring in a solution that the communities reject and it's not benefit the local community. In terms of reaching the net zero, this is the uh, map. You can see gradually we are coming down to net zero by 2050. More than 85% of our building are zero carbon ready. More than 90% of the heavy industry production is low emission. Almost 70% electricity generated globally from solar PV and wind that we talked about, and 90% of the electricity coming from renewable. In terms of heating, we are removing the gas heating that we have at individual house to kind of a heat pump. 50% of the heating demand made by heat pumps, which is uh, electricity driven and things like that. In terms of 2040, we have 50% fuels used in aviation are low emission fuel, synthetic aviation fuel, and things like that. We have all almost IC engine sale is stopped by 2035. So by doing this gradually and gradually, we should be able to meet uh, net zero by 2050. We know the direction of travel is about investing money, educating people, bringing in research, bringing in collaboration, knowledge share, learning from experience from different countries, because different countries is reaching renewable energy or the net zero at different pace. But at the end, we have to achieve that. Otherwise, we'll be ended up with global heating and a lot of environmental disaster. Thank you all for your time and listening to my presentation. That's the end of my talk. Uh, Now think about which energy solution excite you most, maybe something which is very relevant to your country, Indonesia, which have more resources, maybe in hydropower, maybe a nuclear plant, some other thing. Maybe you're thinking about hydrogen and things like that to decarbonize. But as you said, you have to bring solution tailored to your own environment, own country. For further reading, I have IPCC report. Many of my presentation and slide came from IEA, International Energy Agency, and all of the figures that I use is copyrighted or available under license, so it's free to use any of the figure for your presentation. So thank you all. That's the end of my presentation.
Thank you, Professor Mamdud. There is one question actually in the chat box
Yes.
from Rianda Andrika. The question is, may I ask a question based on your experience? Which renewable energy that possible effectively for the isolated area based on financing? So we can replace the thermal power plant like diesel power plant, as we know that to build the renewable energy, it is highly costly compared business to business with cost we must spend for the maintenance and operation cost.
Oh, okay. I mean, for the remote area, maybe the most effective one will be solar energy, solar PV with some uh, battery or storage. Okay, for remote area. Next best thing is that if they have uh, a river nearby and flowing water nearby, so hydrokinetic turbine will be the second options. Or if you have a lot of wind, then we can also use wind turbine. So all any of these three will be appropriate, either solar or wind or hydrokinetic turbine. In terms of maintenance, uh, what we have known is that if you put a solar panel and you have to clean it, okay, otherwise if you get a dust or any other impurity on top of the solar panel, it reduces the efficiency. So you have to have some sorts of local knowledge sharing that you have to clean the solar panel and maintain it properly.
Thank you, Professor.
Yeah, you
There's
were.
two other questions there in the chat box from Ari Tasman.
Okay, I will try to. Good afternoon, sir. I would like to hear your opinion on the most challenging aspect of energy transition based on your experience. What do you think is the greatest challenge achieving net zero emission by 2050? Is it technical aspects such as engineering complexity, financial cost, or non-technical issues such as resistance, policing energy together? Thank you. Okay, so Mohammed Said Nabil, I am answering that. Okay, so that's an interesting question. First of all, if you think about um, electrification, that's the first thing. Because if you can electrify everything, we can have solar energy. In terms of electrification, uh, the in UK or maybe in the world also, wind energy is always in the advanced phase. Wind energy. Next is solar. So these are two is at an advanced level. and those two price has come down significantly, and that can be used for electrification. So EG sector, where easy to implement, these are all done and it's commercially available, commercially viable. So it's not a problem. Now, the main problem will be hard to decarbonize. Something like steel production, where you need very, very high temperature, you need blast furnace kind of thing. Okay. Now, many of the country is using coal-fired electricity because it's very cheap. So there is a scope of economy also there. Okay, so gradually you have to move away from coal into other sector, but different country will have their different financial issues. But in terms of technology, it's already there. In terms of electrification, is as I said, it's not very difficult to have renewable energy in electrification. In terms of transport, electric vehicle is gaining really popularity. Previously, it was talked that hydrogen will be used in car, but I don't think hydrogen will be used in near future. Near future, it will be all electric vehicle. In terms of technical engineering, uh, technical solution is there. Okay, even hydrogen production is there. As I said, it's very costly. We have developed our hydrogen production tool here. It's still very costly, but the technology is there. So I think it's a combination of everything that you have to think of holistically. Okay, that's the main issue. For solar plant, as I talked about, in rural community, you can put solar on the rooftop. You don't use the land for solar panel, but initially we used a lot of land putting solar panel and generating electricity from the using the surface. Now thinking is put the solar panel on the roof or away from the ground so you can have dual use. Some places I have seen they put the solar panel in a pond, so they're doing the fishing at the same time generating electricity from the top. Or I have seen a solar panel put in different type of shade, car park and things like that. They have the solar panel on top of the roof. Okay, that's I answered Mohammed Said Nabil. I go back to
Yes,
what about digital? Okay, digital technology, energy included, with solar and nuclear being so different, how they operate much technology, making them better. Together, my question is AI. Okay. I will come to that in a minute. Can you explain about AI? So we're going fast, but it's not always available. Nuclear is steady, but upfront, it feels like we need the right mix. Yeah. Policy support. My question is, what kind of policy approach do you think can you help balance support between intermittent source, capital heavy ons like nuclear? May I ask? Okay, I'm trying to understand all the questions. So I very similar question in system transition.
Apologies, Mahmoud. There's Mr. Angoro raising his hand. Maybe you would like to address that.
Okay, please.
Silakan, Pak Anggoro.
can you hear my voice? Okay.
A
Please.
little,
Do you hear my
yeah.
voice clearly, Professor Hussein?
Yes, I can.
Oh, yeah. Okay. A question for me is regarding the current policy that the United States have uh, for the energy transition community. So plenty of fundings that has been stopped from the United States, and also they tends to open more into fossil fuels again. So that will be obstacle for energy transition development currently. For example, in geothermal energy area here in Indonesia. So before we have a government drilling programs that would able to help the investment. However, currently is stopped. Maybe one of them is due to the current policy of Donald Trump's. So What do you think about that? About the future of the development uh, correlated to the fundings? Thank you very much.
Okay, yeah, thank you very much for the question. It's actually very much unstable condition. You know, you are hearing the news every day, right? Sometimes tariffs coming in, sometimes tariffs is stop, sometime you see this US aid program is stopped and things like that. Okay, so at the end of the day, I mean, uh, is we first of all we cannot get away from oil and gas for the time being, and maybe next 50 years or so. Number two, we if you think about global warming, for your own existence, you have to do something. So maybe Donald Trump is stopping funding, but there are then other funding available. Even working with UK funding has not stopped yet, and some uh, program I can call it two, three program I think. One is called UK Ayrton grant, Ayrton, and then Innovate UK, and this third project is there. So those projects are there. You have to look for, and if you want to do joint collaboration with us with the UK funding, we can find there. But then, yeah, cost is a big issue, of course. If you don't have funding allocated to particular project, it will be difficult to implement. So a lot of the bigger policy related political question will be probably beyond me from the academic sector to bring some solution.
Thanks for the answer.
Thank you.
Thank you, Pak
Okay,
Anggoro, for
so
the question.
can I take one question first? Is that AI? So you talked about AI and things like that. Uh, I'm not expert in AI, but we have a another set of our colleagues working on AI. So my understanding is that you see that offshore wind turbine, which is quite deep into the sea. How do you maintain that? So if something goes wrong, you have to go there, and to go there, you need a boat. And for the time being in UK, all the supply boat, we call it a supply boat. Those boats are actually big, and these are built for oil and gas industry. Okay, so these carry big and big thing. For wind turbine, we don't need that big parts, but still we are using those type of boat, and it become very expensive supply boat. Sometime for maintenance, we also use helicopter. We fly the people, drop the people on the uh, offshore wind turbine. Uh, to, so to do AI technology, what it does is actually we have gathered information or the data by putting a lot of sensor inside how it is performing. So they are measuring vibration, temperature, pressure, all sorts of data they are collecting and creating a database. From the database, you use machine learning model and look at the pattern and come up with a predictive maintenance tool, and that will tell these parts can fail in the next 3 months or these parts can fail in the next 6 months. That way you do the maintenance, predictive maintenance based on AI data. So you need to have a big data set from the previous experience, and you need to put a lot of sensor to measure those data. Once you have sufficient amount of data, you can train those machine learning tool, and that gives you the predictive capability. So I'm giving you the overall picture. That's the setup, but I'm not expert in AI. So that's how it works.
Professor, we have Miss Intan Kumalasari. Miss Intan,
Please.
please go ahead. Okay, maybe Mr. Yauma Audina, please go ahead.
Okay, thank you, Mr. Mahmud, for your explanation. I have questions. we know that there are many renewable energy options available, and I'm currently working at hydropower plant, which is a clean source of energy that capable of producing a significant amount of electricity, and it is contributing 16%. And however, in my experience, maintaining and ensuring the sustainability of hydropower plants can be really complex. We are responsible for maintaining for the infrastructure, but we also need to manage the environment, which is often fall outside of our direct responsibility. And then also external factors such as climate change can also significantly impact the production. And my question is, how is the management handled in your country, especially in Scotland, right? And particularly regarding on risk management in the face of climate changes in the climate changes in the catchment area, and about the sedimentation issues, how your country manage the risk of that factor. And then additionally, what is the most efficient renewable energy source? Considering, I mean, it is which is the lowest cost, lowest maintenance, and highly profitability. And I understand that location plays a role, and location is really it's really depends on the location. But if we disregard or ignore the location, which is the renewable energy is the most efficient. And lastly, I read in your explanation that while in the future energy seems to focus on nuclear, wind, and solar, why the hydropower not receiving more attention? Okay, thank you, Ms.
Okay, so I mean, I didn't get your question regarding to the risk, but I will answer the last two questions first, and then I will come back to the risk one. So hydropower is actually currently 16% of the 16% of the all energy in the world is supplied through hydroelectric power. So that's the renewable energy. However, its problem is actually related to environment. So if you create a big dam, it create environmental disturbance both upstream and downstream. So that's why, because of these environmental issues, many countries are not taking uh, uh, hydroelectric. But again, if you can manage the environment, there is no harm in exploring hydropower. Okay, so this is a pure renewable energy. Once you put it there, it will be there 60 years, 70 years, maybe 100 years. So it's not a problem. How you manage your environmental impact, and that's the key, nothing else, right? So there is maybe no objection. We should encourage hydropower. Yeah. So in terms of other two questions, if you can remind me.
Which is the most efficient renewable
Okay, so for the time being, the most advanced renewable energy is wind energy and solar energy, and those price has come down significantly. Now, this is the catch. One question also asked about the why it is expensive compared to fossil fuel. Yeah. Uh, why it is expensive compared to fossil fuel? In UK, the price of the electricity generated from wind energy, UK doesn't have that much of solar. It has got wind energy. The price of electricity generated from wind energy is actually based on gas price. Surprisingly, it relates to gas price. So when the gas price going energy, it should be free, but the price we are paying is related to, and is the politics, is the uh, economics, investing. Those who are investing, they want to make a lot of money out of the system, and so that's the politics and economics and investment, return of investment. So surprisingly, the price of electricity generated from offshore wind is actually linked with gas prices. That's why it's expensive. It should be free, cheap. Okay, I think nuclear energy production cost is also very cheap, but maybe installation and a fear of nuclear power plant leakage or things like that is putting it off. Okay, like a number of hands up there.
Thank you,
So
Pak
can
Yama.
you I missed your risk question. Can you repeat me that one, please?
Which one, Professor?
You wanted to ask about risk, which I didn't.
Yes, there was, I think it was, there's 3 hands up here.
Yeah, please
Mr.
go ahead then.
Mr. Ahmad
then
Sharif, or Miss Intan, yes?
yeah. Oh, so sorry first that my camera is not working right, so I can open the camera.
Yeah.
While technology readiness is advancing rapidly, the transition from solar to nuclear energy isn't only a matter of engineering, and it's deeply tied to social acceptance, policy stability, and long-term investment frameworks. And in many regions, public perception of nuclear remains cautious, while solar is more widely accepted but limited by its intermittency. And ensuring a just and trusted transition requires more than innovation. It needs alignment across society, right, Mr. Prof. Mahmoud Amin? So my question is, how can governments and industry leaders build long-term public trust and policy continue to support the dual expansion of solar and nuclear energy, and especially in countries where energy justice and community involvement are still evolving? Okay, thank you.
I personally like solar energy, to be honest.
Okay.
Is something that should be encouraged, uh, and because it's if you want to get a carbon emission down and rapidly transition into net zero, I mean, solar energy is one of the sorry, nuclear energy one of the best. But now we have main issue is the funding cost, upfront cost. I don't know how the funding works. Number one, and number two is human perception, as you say, acceptance. And human perception or acceptance can be changed by having a lot of what do you call human-centric uh, event. So suppose you want to build a yeah, you want to build a nuclear plant somewhere, and the people are living there or something. So you have to have a workshop. You have to have uh, some sorts of uh, public gathering, explaining the technology, taking the people with you. So you can do a lot of public focus activity that will help you to accept those technology. As I said, somebody also asked about these are intermittent, solar and wind. And so if you have a large scale, what you do with that? And also think about base load and so solar and uh, we need not may not be the whole solution. As I said, it some solution, but you need to have a combination of all things. So if you think about the base load, you have to think about what is the best way to supply the best load, and then intermittency you supply from something else, or you have to think about storage. Okay, I didn't talk about storage at all, but that is the another big issue, big challenge, how we store intermittent energy. Some of those storage can be hydrogen. So if we have excess excess energy coming from renewable, we can use that to generate hydrogen. We store the hydrogen, and then we can reverse back from hydrogen to fuel cell to electricity. So from electricity to electricity through hydrogen, I mean, there are system loss everywhere, and the efficiency could be less than 30% or things like that, but similar to thermal energy efficiency kind of thing. But
Professor,
it can be
apologies, we
managed.
have 15 minutes left. Maybe we answer
Okay.
the 2
Sure.
colleagues
Sorry.
here.
Yeah,
Pak
sure.
Ahmad Sharif, silakan, Bapak.
Thank you, Prof.
Okay. Can you hear me, everybody?
Yes.
Yes, yes.
Okay.
Go ahead.
Okay. First of all, thank you, Professor Mamdut, and everyone from UPDL Makassar for the opportunity. Because of our limited time, maybe it's the question I ask you will just 1 or 2 points. Okay. So when I read the material that was shared regarding of the net zero 2050, it just piqued my interest that what you wrote here or what was written here is that the key to achieve net zero by 2050 is what common people could do. I mean, behavior changes, walking, cycling, or public transport for going long haul flights, and that's what common people can do to reduce at the very least reduce the carbon emission. But what about the major company that consumes most of the energy consumptions? Um, is and the way I read the news lately, especially with the existence of cryptocurrency, that consumes a lot of energy, and I can possibly find it right now because
Yeah.
if I paraphrase correctly, the one cryptocurrency production consumes more energy compared to compared to the production of, say, a small city in Argentina or other country like that.
Yes, exactly right.
Is it possible to achieve net zero by 2050, or maybe the target could be postponed, say, to maybe another a quarter century? Okay, that's my question.
Okay, that's a good question actually, because rightly you pointed out, a lot of data center also produce a lot of heat, and you have to cool down the data center. The more we go into artificial intelligence or big data, and if you think about Chat GPT or DeepSeek, they are also consuming a lot of their data center, consuming a lot of heat. Okay, so you have to cool those down, and that also need a lot of energy. Okay, so your question is whether we postpone that net zero by 2050. Um, my answer will be no, because we need to have a target, right? And we work towards the target. Make sure it doesn't create social impact, social injustice, what you call just transition. By trying to achieve something, we don't create more problem for the people. So it has to be people centric, and you have to take people into account at the end of the day. Okay, so whatever you do is for your benefit, for people's benefit. So another advice, not advice, another what do you call, another way to think about, we try to reach net zero based on our own context. Don't try to follow context from other country or take advice from other country. Whatever good for your country or my country, that what you follow, right? We are under Scotland. We have a semi-independence. Some area we can work, some area we cannot work. So also we don't like a lot of things. We want to do something else, but we are forced to do from the UK government and things like that. So exactly, I ask exactly what you said is totally right. We have to develop our own policy based on our own circumstances. Okay, Reynold is there. Did I answer your question? Are you okay?
Yeah, okay, so far that answers my question. Well, maybe next time we can have a discussion again. Thank you, Professor
Sure,
Mamdut.
sure. Thank you.
Thank you, Pak Ahmad. Pak Reynold?
Reynold.
Reynold, yeah.
Hello,
Hello.
good day, good afternoon. Here the fun fact is that we all of us have the same opinion that first of all, renewable energy such as solar and etc. is the intermittent, and the stability we still need the power plants such as
Yeah.
geothermal steam from fossil. And
Yeah.
as you previous conversation that we need to provide our own policies as what we have in our own country.
Yeah.
I have never been in Aberdeen, but I am a fan of Sir Alex Ferguson because I am a
Yes.
Manchester United fan and he's Aberdeen. But
Yeah.
in your country, in Aberdeen, especially previously, what power plant do you use to provide your own electricity? And if there any steam power plant based on fossil, what do you do with them? Are you all demolish them, or you change the technology to use other, such as we in Indonesia we use co-firing. So the combination of coal with some others, because we have
Okay.
on maybe we have from the sea, from the wind, from the solar, we have from other uh, from trees, such as like that. So in your country, what do you do to your previous power plant, and what technology that supposed to be our path to the net zero emission without, or we can less eliminate the power plant existing. Thank you. That's all. Thank you,
Oh,
Prof.
thank you. So first of all, we have gas turbine. Number one. Number two, we had coal fired one. We tried to put carbon capture and storage on top of coal fire, but it becomes very expensive and technology didn't work. So we stopped the coal fire altogether. As you said, demolished it. Okay. There is no more coal fired power plant in Scotland. We have gas turbine, and we have solar here. We also have uh, uh, hydropower. But these are small plant. Hydropower, we have in a river, we put some small dam. It's not very big. And so we have quite a number of hydroelectric power plant, which we almost like forgotten. We don't talk that hydropower is one of the renewable energy we are generating. So most of our focus now is wind. It started off with near shore, maybe 10 meter into the water. Now it's going away up to maybe 50 meter to 100 meter floating offshore. Okay. One of the idea is that if you can generate excess wind energy, you can convert into hydrogen and pump that hydrogen to other countries which doesn't have wind, which doesn't have, but they need energy and they don't want to use natural gas anymore. So hydrogen will be transported to Germany, to Holland. Already existing subsea pipeline is there, so we can repurpose those pipeline. So your question is, yeah, we demolished some of the power plant, and, but uh, it's a energy mix. It's a balancing the network, which is not my subject area. I don't have the expertise. But when I talk with electrical engineers, we talked about smart grid. We talked about distributed network. We talked about uh, demand management and things like that, but we are stuck with the old grid system. So we really need to spend money and come up with a smart grid or new grid system. We don't have that. And money is a problem here also. You'll be surprised to hear that our funding is also very, very tough. Okay, so
You are
just
breaking up
transition,
on the
because
feed,
if
right?
you can keep oil and gas, it's good for Aberdeen also, because we made lot of we got the prosperity from oil and gas, especially for Aberdeen city. But as you said, Alex Salmond and the government policy changes, so we have to have a just transition. But there is no silver bullet. We just work towards and see which one could be effective, which could be people can accept that. We take people. We have to. My always my feeling is to we have to look at local technology. Whatever good for UK may not be good for Indonesia. Maybe we don't know the local structure that much about Indonesia. Maybe we have a lot of your hydroelectric, maybe a very good thing there, or nuclear plant. Always, I support nuclear plant myself. So, though that's not my research area. Thank you all.
Thank you,
Terima kasih.
Professor.
Thank you.
Yeah. Any other question? Yeah. Okay.
Yeah, Professor, I think the time is, we have 5 minutes left. So
Okay.
all the other questions that has been written in the chat box will be sent to us, Professor, and then later on, I will convey that to you.
Oh, excellent. That's very
Yeah.
good.
Oke, terima kasih Bapak Ibu yang terhormat dari PLN. Kembali saya memperkenalkan diri, saya dengan Miranda dari Robert Gordon University. Terima kasih atas kehadirannya sore ini. Mudah-mudahan sangat membantu ya untuk kelancarannya. Saya kembalikan ke Mbak MC, Mbak Eliana. Terima kasih.
Thank you, Ms. Miranda, being our moderator today. We will remain for any remaining question in the Zoom chat. Please refer to the question link provided as Professor Mamdut will be happy to respond to them there. Feel free to check your answer there.
Thank you very much.
Thank you very
Bye-bye.
much, Professor
Bye-bye.
Mamdut Hossein, for the
You.
valuable
Bye-bye.
and engaging
Thank you,
presentation.
sir. Thank you very much.
Thank you, sir.
Terima
As we
kasih.
come to the end of this session, please allow us to express our appreciation on behalf of PLN by presenting a certificate of recognition, which we will now display on the Zoom screen. Okay, thank you, Professor Mamdut Hossein again. Ladies and gentlemen, we have arrived at the end of today's knowledge sharing with Professor Mamdut Hossein from Robert Gordon University. Thank you, Professor Mamdut Hossein, Ms. Kezia, Ms. Sarah Eliar, our moderator, Mr. Miranda, and all our participants in here. I hope this event gives you a valuable knowledge and also broaden your view about the renewable energy. On behalf of PLN, we extend our deepest gratitude to our distinguished speaker and moderator, as well as PLNers, for being a part of enlightening event. Once again, thank you, Ms. Kezia, Ms. Sarah Eliar, Ms. Miranda, and Professor Mamdut Hossein, and PLN Corporate University team. See you at the next Global Expert series. Have a good day, everyone, and thank you.
Terima kasih, sampai jumpa.
Terima kasih. Selamat sore. Sampai jumpa.
Selamat sore. Terima kasih, Bapak
Iya, Bu
Ibu.
Soma.
Terima kasih, matur suwun semuanya, sahabat-sahabat.
Thank you, thank you. Terima kasih.
Terima kasih. Selamat sore semua.
Jangan lupa PLN kliknya di pencet. Jangan lupa cek outnya Bapak Ibu. Absensi.